Hi class, here's our first video lesson for 4-1. For chapter 4, we're on 4-1, we're classifying triangles. There are three different ways to classify triangles by their sides. We can either call a triangle a scalene triangle. Of course, every triangle has three sides, and in a scalene triangle, all three sides are different lengths. So none of the two sides, or none of the three sides, are congruent. In an isosceles triangle, two of the sides are congruent to each other. So that's oftentimes noted with like a tick right here and right here. In an isosceles triangle, of the three sides, two of them are the same. And in an equilateral triangle, equal, that would mean that all three sides are equal, or all three sides are congruent. All three sides are the same length. So that's how you classify a triangle by its sides. Every triangle is either scalene, or isosceles, or equilateral. There are four ways that you classify a triangle by its angles. You can call it an acute triangle if all three angles are less than 90 degrees, or if all three angles are acute. So this angle might be 63, for example. This one might be 39, for example. And this one might be, oh, whatever, another acute angle, whatever it might be. All three less than 90. Obtuse is where one of the angles, so and again in a triangle there's three sides and there's three angles, one of the angles is obtuse or greater than 90. It's impossible for two angles to be greater than 90. So an obtuse triangle is when one angle, such as this one right here, is more than 90 degrees. It's obtuse. A right angle is where one of the angles is exactly 90 degrees. So one of the angles is right, or 90. So in this case, it'd be that one right there. And just like equilateral is all the sides are equal, equiangular is when all of the angles are equal. So in a way, an equiangular triangle is acute because all three angles are less than 90. But then to be even more specific, all three angles are congruent. So that would mean that those three angles are actually all 60 degrees, but they're all equal to each other. So three ways to classify it by its sides, four ways to classify a triangle by its angles. Acute triangles, obtuse triangles, right triangles, or equiangular. Alright, find D and the measure of each side of an equilateral triangle KLM. If KL is D plus 2, LM is 12 minus D, and KM is 4D minus 13. In geometry, we deal with a lot of shapes, a lot of pictures. Let's draw ourselves an equilateral triangle. Might be a little bit easier for me, but you guys can sketch one as best you can. Just draw a triangle on your paper. And let's call the triangle KLM. It doesn't matter where you put the vertices, but just put K at one point, L at another point, and M at a third point. So it says KL is D plus 2, and LM is 12 minus D, and KM is 4D minus 13. 4D minus 13. Now all these are side lengths, they're not angles. So if we take a look at what we're given here, if it's each side of the equilateral triangle, equilateral means all three sides are equal to each other. So this one, KL, is congruent to LM, is congruent to KM. All three sides are congruent to each other. So when it says find D in the measure of each side, there are three different ways I could solve this. I know that KL is an equal distance to LM. I know that LM is a congruent distance to KM. And I know that KM is a congruent distance to LK. So I could set any two of the three of these sides equal to each other and solve for D because they're all congruent to each other. So it really doesn't matter. So I'm going to set KM equal to LK. So I'm going to set 4D minus 13. It's equal to the other side, D plus 2. In an equilateral triangle, they're all equal to each other. Let's solve for D, shall we? We'll subtract D from both sides and add 13 to both sides. and you get 3d equals 15. Divide both sides by 3, so we would get d to equal 5. Please write that down in your notes. What I'm just going to do right now, everybody, is I'm just going to prove that you could set any two of them equal to each other. So if you don't want to write this down, you don't have to, but I'm just going to set d plus 2 equal to 12 minus d. D plus 2 equals 12 minus d. And if we did this correctly, they should all be equal to each other, so d should be the same. So we should get d to equal 5. Let's see if we do. Add d to both sides, and then we would get 2d equals, subtract 2 equals 10. Divide both sides by 2, and voila, again, you get d equals 5. So it really doesn't matter what two lengths you set equal to each other, because in an equilateral triangle, they're all equal. So we have found d. That's wonderful. Now it says, and find the measure of each side. So let's go KL and LM, I think, and KM. LM and KM. So KL here is d plus 2. So it is 5 plus 2, which is 7 units. It doesn't give us a unit, so we'll just call it 7 units. LM is 12 minus d. So 12 minus d, and d is 5. 12 minus 5 is 7 units. And then KM is 4 times d minus 13. 4 times d minus 13. 4 times d we found to be 5. 20 minus 5 is 13. Isn't that something? Isn't that something? They are all 7 units, which it should be that way, right? Because it's an equilateral triangle. So d equals 5, and all 3 sides are 7 units. Next one, again, it's a picture of an equilateral triangle. This time it says find the value of x, y, and also the perimeter. So again, all 3 sides are equal to each other. So this one is equal to this one is equal to this one. However, this one's different than the last one in that I cannot set these two equal to each other and solve for x or solve for y, because there's 2 different variables there. In the same way, I cannot set these two equal to each other, because I can't get a variable all by itself equaling an integer, or equaling a number, rather a solution. So there's only one pair of sides that I can set equal to each other, the 2 that have the same variable. Let's set these 2 equal to each other to find x. So that side, 2x plus 11, equals the other side, 4x minus 1. Let's now solve for x. Subtract 2x and add 1. So we would get 12 to equal 2x. So if 12 equals 2x, then x has to equal 6. So we found the value of x. That's good news. X equals 6. Now we want to find the value of y. Well, if I substitute x back in here, 2 times 6 is 12, and 12 plus 11 is 23. So this side right here is 23. And that means this side is also 23. And that means this side is also 23, right? All 3 sides are equal to each other in an equilateral triangle. So 3y minus 4, that length is 23. So it equals 23. So we set that side equal to 23. Then I add 4, and I get 3y equals 27. Divide both sides by 3, and I get y to equal 9. So I found x, it's 6. I found y, it equals 9. And now I want to find the perimeter. So if I substitute all my values back in, we just said when we substitute 6 back in, we get a 23 right here. If I substitute 6 into this x, 4 times 6 is 24, and 24 minus 1 is once again 23. We're looking good. For the third side, we should also get 23, but let's make sure we put 9 in here. 3 times 9 is 27, and 27 minus 4 is 23. So, what is my perimeter if an equilateral triangle has a side of 23? The other side is also 23. The other side is also 23, and we get 69 units. So the perimeter, 69 units. There is the answer, x, y, and the perimeter for this question. Last one for the day. It says, find the measure of the sides of triangle RST and classify the triangle by its sides. Oofta. Let's graph this sucker, shall we? Let's put these 3 points on our coordinate grid. R is left 1, down 1, 2, 3. Here is R. And S is right 4, up 5. There is point S. And point T is right 8, down 2. There's T. So if I draw my triangle, it's looking like this. So question for you. To classify it by its sides, there's 3 ways to classify it by its sides. Is this a scalene triangle? Or is it isosceles? Or is it equilateral? It's got to be one of those 3, because when you classify a triangle by its sides, there's only 3 options. So are all 3 sides equal to each other? Are 2 of the sides equal to each other? Or are none of the sides equal to each other? So how do we find out if the sides are equal? Well, we've got to find the length of each side. So we have to find the distance of each side. We have to find the distance of each side. We have to find the distance of each side. What's better than doing the distance formula once? Doing it twice. What's better than doing the distance formula twice? Doing it 3 times, right, everybody? We're going to do the distance formula 3 times to find the length of all 3 sides. So first, let's find the distance from R to S. Here we go. The distance from R to S is these 2. So it's x2 minus x1 squared plus y2 minus y1 squared. So we get 4 plus 1, which is 5. 5 squared is 25. 5 plus 3 is 8, and 8 squared is 64. So the distance from R to S is the square root of 25 plus 64, which is the square root of 89 units. So RS, we can put that in our calculator, but for now we'll just keep it as the square root of 89. Alright, let's find the distance from S to T. So the distance from S to T is between those 2 points. So here we go. The distance from S to T equals the square root of x2 minus x1 squared plus y2 minus y1 squared. 8 minus 4 is 4, and 4 squared is 16. Negative 2 minus 5 is a negative 7. Square negative 7 to get a positive 49. So the square root of 65 is the distance from S to T. The square root of 65. So right now we have ruled out equilateral. In an equilateral triangle, they all have to be the same length, and the square root of 89 and the square root of 65 are different lengths. It still could be isosceles, or it could be scalene. So let's find the distance from R to T. So it's from this point to this point. Let's find the distance from R to T. So the distance from R to T equals the square root of x minus x, 8 subtract a negative 1, squared, plus y minus y, a negative 2 subtract a negative 3 squared. 8 plus 1 is 9, and 9 squared is 81. And then a negative 2 plus 3 is 1, and 1 squared is 1. So my distance is the square root of 82 units. The square root of 82 units is the distance from R to T. Square root of 89 and square root of 82, they're pretty close to each other. They're both right around 9 units. Can I say that it's isosceles? No, I cannot. You cannot say it's isosceles unless two sides are exactly equal to each other, unless they're congruent. So it's not isosceles because all three of those are different lengths. So this sucker is a scalene triangle. I hope that this made sense to you. There's 4 ways to classify it by its angles, 3 ways to classify a triangle by its sides. Let me know if you have any questions when you get to class tomorrow.